Hi, welcome to video 5. In this video, we're going to work with the perfect substitutes utility function, and we're going to do some optimal choice analysis and also derive demand functions for goods X and Y. So to get us started, let's assume we're going to work with the following utility function. Utility equal to X plus Y. And for the examples we'll work with in this video, I'm going to let X be one type of diet soda. We'll call X Diet Dr. Pepper. And good Y will be Diet Coke. And in the example that we'll work with first, we'll be doing some optimal choice analysis. And for this example, we're going to assume that our consumers got $20 per week to spend on Diet Dr. Pepper and Diet Coke. We're going to also assume that the price of good X, in other words, the price of a can of Diet Dr. Pepper is 50 cents, and that the price of a can of Diet Coke is $1. When we try to figure out how we're going to solve this optimal choice problem, we need to remember that there are basically two conditions that we have to check when we look at that utility function in order to see if we might use Lagrange's method to do the optimal choice analysis. So the two conditions that we have to ultimately think about the utility function satisfying, it has to be differentiable, and then the indifference curves for the utility function need to be downward sloping and diminishing MRS. So let's go ahead and think about graphing a few indifference curves for this utility function, and we'll get a chance to verify if this utility function actually satisfies these two properties. So on the set of axes that I've got sketched out here, I'm just going to sketch in a few indifference curves. I'm going to sketch out the indifference curves for u equal to 20 and u equal to 40. And so in order to sketch out any one of these indifference curves, I'll plug that utility value in, and then if I want, I can go ahead and solve explicitly for y, and that gives me a nice, easy equation that I can go ahead and graph. So I'll do the second one here. Okay, so we've got these two indifference curves graphed, u equal to 20 and u equal to 40, and we can see from just visually inspecting them that ultimately these are obviously downward sloping, but the marginal rate of substitution is not diminishing. In fact, it's going to be constant. So we're not going to be able to use Lagrange's method in order to solve our optimal choice problem. Instead of using Lagrange's method, what I'm basically going to do here is just solve this problem using intuition and graphical analysis. So what I need to add to my graph is a budget constraint. So I'm going to write out the equation for my budget constraint. Again, the price of cans of Dr. Pepper, 50 cents. The price of cans of Diet Coke was $1. And our consumer had $20 to spend on these goods. So if I go ahead and sketch in this budget constraint, I've got that sketched in blue. You'll notice that this graph has got the potential to be a little bit confusing because we've got indifference curves that are linear and we have the budget constraint that's linear. You're used to seeing the linear budget constraint, but linear indifference curves are going to be a little bit different than if you've looked at, say, Cobb-Douglas or some other utility functions that have nice, well-behaved preferences. But hopefully what you can also see from this picture, if I were to sketch in some additional indifference curves, and I'll do that in black, as I look at that field of indifference curves and I look at the blue budget line, there are a number of different points that I could think about as being a possible optimal choice. So for example, I might think that bundle A or bundle B or bundle C might be my optimal choice. So if we start at bundle A, you'll notice that at bundle A we're on that U equal to 20 indifference curve that we had sketched in earlier on. So my utility, my total utility would be 20 units at bundle A. But if I keep moving out along my budget constraint, you'll notice at bundle B, I'm on a higher indifference curve. So I'm definitely better off than I was at A. And if I keep moving all the way down my budget constraint, you'll notice that at bundle C, I've actually maximized my utility. I've gotten to the highest possible indifference curve. Now, another way that we can verify that I should be buying only good X, which is what we're seeing the consumer do at bundle C, you'll notice that the marginal utility for good X is 1. The marginal utility for good Y is 1. So in the context of my example, we know that I get 1 additional unit of utility from every can of Dr. Pepper that I consume, that's good X, and 1 additional unit of utility from every can of Diet Coke that I consume, that's good Y. But you'll also notice if we put marginal utility over price, for good X, that's going to end up being a constant value of 2, and for good Y, that's going to be a constant value of 1. In other words, what this is telling me is that the bang for the buck that I get from good X is always going to be higher than the bang for the buck that I get from good Y. In other words, what this is really pointing me to is exactly what I see in the graph, and that is spend all of my money on good X. Now that we've done some optimal choice analysis, let's turn our attention to trying to derive the demand functions for good X or good Y with our perfect substitutes utility function. So you'll notice in this picture what I've done is I've sketched in a series of 4 different indifference curves. And again, these just have general labels, but the basic idea here is that the marginal rate of substitution for all of them is constant. And we know that the marginal rate of substitution is going to be MUX over MUY. And in our previous slide, we saw that the MUX and MUY values were the same. Those are both 1. So in absolute value, the slope for each and every one of these indifference curves is just going to be 1. Well, our basic problem that we're looking to do with deriving a demand function is very similar to what we had done with the optimal choice analysis. Again, we're looking to maximize the consumer's utility subject to their facing a budget constraint. The key point with the demand function, though, is we're trying to find a general recipe that will allow us to find the optimal amount of X or the optimal amount of Y given prices and income. So what we need to do here is, again, think about some graphical analysis and using good economic intuition to try to derive this demand function. Because as we had seen with the optimal choice analysis, Lagrange's method isn't going to work well for us. So what I'm going to do is I'm going to start with what I'm going to call case 1. And in case 1, what I'm going to do is sketch in a budget constraint, and I'm going to make that budget constraint pretty steep. Now, the key point for case 1 is you'll notice that the slope of that budget constraint, which in absolute value would be px over py, the slope of that budget constraint is greater than the marginal rate of substitution. Now you'll notice as you look at that picture that the very best indifference curve that my consumer can reach when facing that red budget constraint would be right up here at what I'll label bundle A. And at bundle A, the consumer is choosing 0 units of good X, in other words, 0 cans of Diet Dr. Pepper, and what they're doing instead is spending all of their income on good Y, in other words, Diet Coke. So we just need a mathematical expression for how we would write down spend all of your income on good Y. And we can ultimately write that down in the following way. We just take our income and divide it by the price of good Y. So that's case one. That's going to apply anytime the price of good X over the price of good Y is greater than the MRS. Stated a little bit differently, given the numbers that we have, it's going to happen anytime Px over Py is greater than 1. I'm going to skip ahead to look at a different case now. I'm going to call this case 3. Case 3 is going to involve my drawing a budget line that's going to be really flat. Now, the key thing here is you'll notice that the budget constraint is actually flatter than any of the indifference curves. So in absolute value, the slope of that budget constraint, Px over Py, is less than the marginal rate of substitution. In other words, Px over Py is less than 1. Well, when facing that green budget constraint, my consumer is going to reach her very highest indifference curve out here at what I'll call bundle C, and ultimately the consumer will be on indifference curve U3. Well, at bundle C, my consumer's not buying any cans of Diet Coke. Instead, she's spending all of her money on good X, in other words, all of her money on Diet Dr. Pepper. So right now, we've got two cases, case 1 and case 3. If the ratio of the prices, in other words, if the slope of the budget constraint is steeper than the indifference curves, I am going to be in a situation like case 1, don't buy any of X, I spend all my money on good Y. Case 3, if the slope of the budget constraint is flatter than the marginal rate of substitution, then I spend all of my money on X and I don't buy any of good Y. Those two cases will cover the vast majority of the possible price combinations that we might face, but there's one last possibility that we've got to consider. So this is case 2. And this one's a little tricky because here we're looking at a situation where our budget constraint is going to be exactly equal to the marginal rate of substitution. In other words, when I sketch this in, the budget constraint is going to fall right on top of that indifference curve that I've labeled U1. So we have to ask ourselves, all right, well, if the budget constraint is right on top of that indifference curve, where will the consumer choose in order to maximize her utility? And the answer is that it is ultimately not clear which point she might choose because all of the points along that budget constraint, anything on that blue/black line, all of them give her the same amount of utility. So they're all utility maximizing choices. So if we're going to write that down, what we need to say is that the consumer can choose an amount of X anywhere between 0 and spending all of her money on it. And similarly, she can choose an amount of good Y between 0 and spending all of her money on good Y. Now, clearly she can't spend all of her money on good X and good Y simultaneously, so she's got to satisfy her budget constraint, but she can basically choose any point that's on that line that falls within each of these intervals respectively. It may not be obvious at this point that we've actually finished everything we need to do in order to write down the demand functions for goods X and Y, but we actually have. So what I need to do is write down this function that's going to have different parts to it. Basically, the three parts that I'm going to write down will correspond to each of the three cases that we had seen on the previous slide. So, the consumer is either going to choose to buy 0 units of good X, and again, X is cans of Diet Dr. Pepper, so either 0 units of good X, going to choose somewhere between 0 and spending all of her money on good X, or she'll choose to spend all of her money on good X. And what we basically have to do to finish off this demand for good X is we have to write out some conditions. I'll go ahead and color code the conditions so that you can match these up with the previous slide. So the consumer is going to choose 0 units of good X if Px over Py was greater than the marginal rate of substitution. The consumer is going to choose to spend all of her money on good X if Px over Py is less than the marginal rate of substitution, and she'd choose to be somewhere in that interval, the middle case, if Px over Py is equal to the marginal rate of substitution. So if we turn our attention to writing down the demand for good Y, again, it's going to be piecewise. The one thing you want to be careful about here, you want to be very careful to match up the cases. So the consumer is going to spend all of her money on good Y when we were in case 1. That's when Px over Py is greater than the marginal rate of substitution. On the other hand, she was going to buy 0 units of good Y if we were in the third case. Oops. Get that cleaned up. If we were in the third case and Px over Py is less than the marginal rate of substitution. And then finally, be in the middle case, case 2, if Px over Py is equal to the marginal rate of substitution. So that puts everything together for us, and we've now completed our task. We've derived the demand functions for both goods X and Y.